When scientists think about it, I think they're understanding not philosophy as a discipline, but they're thinking about a worldview. And we come to everything with a worldview, with a lens.
Okay.
That's inescapable.
I leave all philosophical preconceptions at the door.
You can't do that, though.
To the extent that I'm able. I'm self-aware that I could be constrained by a philosophical thought.
Your choice to set aside some world, like, so that you can be neutral,
Yes.
is itself a philosophical position.
Oh,
Okay.
That's a very
That is
good
ineliminable.
point. She's about to say, that's like being a little bit pregnant.
This is StarTalk. Neil deGrasse Tyson, your personal astrophysicist. I got Chuck Nice with me. Chuck it, baby.
Hey, what's happening, Neil?
All right.
Oh, yeah.
Love it when I look over and I see you there.
Oh, the feeling's mutual.
Oh, thank you.
It's almost like I'm looking at myself.
So, we're doing something we haven't yet done on this show.
All right.
We're going to do the philosophy of physics.
What?
I know.
That's why we haven't done it.
And we had somebody right up the street.
In the hood.
Actually, literally in the hood, up in Harlem. And this is Elise. How do I pronounce your last name?
Crull.
Crull.
Yeah, Elise Crull.
Elise
Yep.
Crull. Welcome to StarTalk.
Hey, thanks for having me.
Yeah, so
Yeah.
you're a professor of philosophy in the philosophy department.
That's right. Yep.
So this is a CUNY.
Yep.
Yeah. And you authored a book just last year, came out, but it was like a very serious academic tome, The Einstein Paradox. This is a very seductive title, okay? Einstein Paradox, the debate on non-locality and incompleteness.
Ooh.
Oh, come on. Oh, in 1935.
Yeah. So the title actually comes from Schrödinger. He had a folder in his archives.
Schrödinger.
Of
cat fame.
Of cat fame.
Yes.
And
Right.
in fact, the cat was born in this correspondence with Einstein that he had labeled in German, the Einstein Paradox. And so we translated those letters into English, many of them for the first time. And it's all the famous physicists talking to one another about what this physics is.
So why can't regular people read this?
They sure can. It's just that the primary literature in particular, just reading the way that Einstein and Schrödinger and Heisenberg and Bohr talk to one another.
They had their own language.
Wow.
Yeah, okay.
They did. And they had their
Like
own...
twins.
Oh, yeah, they just have their
Like
own
twins
thing.
that get their own language.
Yeah, yeah.
Except in this case, their own language was often German. Some cases Danish, but their
Danish
own
would be for Niels Bohr.
That's
yeah,
right.
yeah.
That's right. But they all had a really nuanced like they had different ideas about what was problematic about quantum mechanics.
Interesting, because
Interesting.
quantum mechanics is just being born
Right.
at that time.
It's
yeah.
about 10 years in at this point.
Yeah.
And what precipitated this was Einstein had conversations with two guys, Podolsky and Rosen, about what he felt was an issue that quantum mechanics was correct, but it wasn't finished yet. It wasn't complete.
And guess what? He was right.
Still, it's incomplete. So that book is by Cambridge University Press, which has quite the catalog of astronomy and physics books for the public.
Yeah, and I mean, the book is intended for people who are interested in learning from the physicists at that time themselves, their philosophical and physics sort of worldviews, and learning about this history.
I don't understand the use of philosophical when it comes to their physics.
Well, let's start right there. Let's just.
good.
You are a professor of philosophy specializing in the philosophy of physics.
Yeah.
So what is the philosophy of physics in modern times? Because I know what it was in the day. Because in the day...
What's the day? Antiquity or the Renaissance?
No, Newton. Yeah, post-Galileo.
Okay. Newtonian worldview.
Yeah.
Okay, got it.
Yeah, back then...
Scientific revolution.
Yes. Back
got
then, philosophers were physicists. I mean, they
That's
were
right.
one and the same.
That's right.
And in fact, Newton's greatest work has the word philosophy. The word physics isn't even in the title.
That's right. The Principia doesn't even have equations in the first part.
Okay.
That the title is, well, in Latin, but it's the mathematical principles of natural philosophy.
Okay.
That's right. Natural philosophy.
Natural
same
philosophy.
Yeah, natural philosophy was physics. It's the deep thinking about how nature works. Okay.
Yeah.
So we got that. But into the 20th century, you get quantum physics where you can't deduce from an armchair, and you have expanding universe.
Right.
Who thought that up?
Right.
And so
the confirmation of all these things that were
experimental.
mathematically postulated and then proven to be the actual case.
So what I've noticed
was
that there was a sort of a separation of the turf.
Yeah.
And the philosopher couldn't really contribute to physics unless they were actually a physicist. They could still think philosophically, but you needed to be in the lab. You couldn't just sit back and observe and think deep thoughts.
Well,
about what the
Einstein was
universe
never in a lab.
Right, but he was a physicist, not a philosopher.
I don't think he would make that distinction.
Let me say it differently.
Okay.
He was trained as a physicist, not trained as a philosopher.
Oh.
And that's the distinction I'm making.
So here's the real test.
That is the
Actually,
distinction I'm making.
If Mel Brooks were doing a sketch with him, would he say to Einstein in the philosopher unemployment line, did you bullshit today? Did you try to bullshit today? Are you planning on bullshitting in the future?
Is that from History of the World?
History of the World.
Yes, yes.
That's History
That's
of the World.
actual quote. Yeah. So I'm distinguishing between people who go to school to be a philosopher and then attempt to contribute to the physical sciences, whereas that you could do that in the day. And I don't see that happening today unless you're busting that wide open in your existence in the world and in this office now.
Yeah. Okay, couple of comments.
All right.
First of all, in the German university system in which Einstein and Schrödinger and Bohr and all these guys were trained, they learned a hell of a lot of philosophy.
Sure.
And even Einstein into his
I'm not saying people didn't have philosophy chops. I'm saying if you go to school to be a philosopher, in the 20th century,
Fair enough.
you became less and less useful to the moving frontier of the physical sciences. That's the only point I'm making. Now go. Unless you're going to bust that open.
Well, the first thing is I don't accept your premise that in order to
That's
do
how
what
you
I do,
start an argument.
That's how you start an argument. I think
How you start and win an argument.
We're well on our way into a philosophical debate.
Your premise is invalid. Okay, go.
well, a premise can't be invalid. Only a whole argument can be valid. But I'm being an asshole on purpose because it's funny. The idea that what I need to do is be useful to science, to be important or worth doing as a human endeavor, is a pretty narrow view.
Except that's how it used to be. And that's
what used to be?
Philosophers were useful to the moving frontier. You have Kant thinking up stuff that the nebular hypothesis was kind of cool. And you had...
so Einstein's own ability to get the theory of special relativity had to do with his taking a different approach than Lorentz and Poincaré and others who were looking for a similar theory.
Yes,
He said, let's step back. That is a that is a choice to step back and say, we have these data, let's understand them a different way.
I'm not saying...
Now, if you're saying it's about how we specialize into different disciplines, yes.
Yes.
That is something that naturally occurred as our measuring apparatuses and our technology got better.
Got it.
We were able to be and you go to a conference in astrophysics nowadays, how many talks do you even are interested in talking, like hyper specialized? Fair enough.
Yeah, I publish a paper, 100 people in the world will understand it. Or no, 100 people in the world will care about it.
Right. For me, it's like maybe 6.
Oh, there's worse.
They're my buddies,
God.
Okay, yeah.
Okay.
It's like when people are like, oh, how do I find you on the internet? I'm like, Google Elise and philosophy of physics, because I think I'm the only one.
So let me back up as a layperson and kind of broaden the view here. The intertwining that Neil was talking about that existed at one point, that you now say has kind of dissolved because of highly specialized training.
Yeah.
Where does that intersection happen now?
Good. Yeah.
Good question.
That's great. And I think that's exactly the question we want to. So you're asking, am I going to blow it open now?
Yeah.
I think the fringe, like the
I'm
edge
waiting
of
for that
the
philosopher
edge
to
of
come along.
science right now is in this place. So you're talking about people who are looking for
In
a
this
theory
place?
of
In my office.
this place.
In this place.
In this place, metaphorically and
This is my
literally.
office at the Hayden Planetarium.
Right now.
It happens here and now.
Localized entirely in this room.
We're in the room where it happened.
Okay. Okay.
We're getting beyond our means to empirically test. And you know, as a cosmologist and astrophysicist, there's a limited amount of data that we...
On that frontier, yes.
On that frontier. And that's true also in looking for theories of quantum gravity.
Yeah, all of that.
I mean, we haven't yet found conclusive evidence for the lambda CDM model that is only for the lambda CDM model of cosmology. It's the best we have right now. But
It's the cold dark matter and dark energy. It's just...
The concordance, like the model we think is the best model of the universe right now.
Just catch people up. So we know the universe is accelerating in its expansion, and what's causing that we call dark energy.
Right.
We just call it that.
Yeah. Right.
We don't know.
But it's a black box, quite literally.
And then dark matter
Right.
is a mysterious source of gravity in the universe. In fact, it's 85% of the universe is gravity. And we don't know what that is either. But if we assume it's a thing, because we measure it,
Right.
and then we can calculate with it, and with some assumptions about the behavior of matter, we get a sort of a kind of our own standard model of how the universe works. It's called lambda CDM, lambda
cool.
called dark matter. And we work with it. It gets us some understanding.
Yeah, it does some good work for
we
you.
did some. It's our
we
workhorse,
don't have
but it's not a
direct-
complete
It's not a complete picture.
complete theory.
Right.
Okay.
Right. So this is true in a lot of arenas of physics. And so what philosophers of physics can do, although I think there are many ways to be a philosopher of science, is
general,
not just
in general.
like you're trained in philosophy, but you sort of ask philosophical questions of science itself.
How many philosophers of physics are there?
I don't know. More than 5, but less than 200?
Okay.
Well,
No, maybe there's
All right.
more than 200. It's hard to say.
You're the first one I've ever met.
Oh, really?
Yeah, I've met philosophers, but just think about everything.
Right.
You know.
It's a small field, to be fair.
Right.
And I will also say, back to your early point, most of us have training in physics as well, because that's important to us. Like what
You're
I
undergraduate.
do. My undergrad is in physics, but then I also continued. I mean, I wrote my doctoral thesis on quantum decoherence. So, like, I was learning about the models that
Okay,
people
so
are
you gotta say
using.
you're
Yeah, physics
qualified.
chops.
Yeah.
So
But
was
you
that in the
have to.
physics department or the philosophy department?
So I was in the philosophy department, but I was part of a history and philosophy of science program. But I also took a number of physics courses.
From the physics department. Okay, so
Yep.
you just blend in all of
the
that.
things.
You just put it all
really cool.
together.
However,
That's what we need for someone to
that's
bust
a
out.
great way
To bust a move.
That's a great way to make sure that you get an A. Is
Why?
that
Why?
Because
What? Yeah. What is? How does that correspond
how
to
does-
getting a good
here's
grade
how
at all?
here's how it works for getting a good grade.
Oh, good. I'm
so
listening.
you have your philosophy people, they don't know crap about physics, and your physics people, they don't know crap about philosophy. So you're just like, yeah, you're gonna have to take my word for it.
That's exactly right. We're all just pretending. Right?
No, go
but-
ahead.
So this ties into your earlier question. Is like something about the extreme specialization has meant that, in particular, the way we train physicists in the U.S., even in high school, is so divorced from the deep questions about but why and but how. It's about following a
We say in the
scientific
U.S.
method.
Did you study abroad?
No, but I've looked at education policies in other countries, and sort of
Really?
it's no surprise that
That we're messed up.
that we're not, we're still the best place to go for STEM at the graduate level.
Right.
But we're losing that.
Yeah.
And there's a history about that. In particular, there were decisions made in the Cold War era to train people in science in a particular way that was going to get technologies built, that was going to be good for industry and for the
Results-oriented.
Department of Defense.
Right.
That's right.
Weaponry.
And it became not just not in vogue, but like it
In
became
fact, I have the original document in this office.
of the NSF creation of
Yes,
of
I have
yeah.
that document. Can I reach for it?
Yeah, show it.
Ma-
Show
ma-
it to
ma-
us.
Yeah.
Let's have a visual here.
This is what you're talking about.
Yeah, Vannevar Bush
Let's let our people at home
making
check.
a case for why America needs to preserve and fund science.
And I think that was an easy case to make because it was physics that won the war.
Well, that definitely helps an argument. I'm just saying.
But there's a This is good. This is good.
Okay.
That's funny. That's funny.
Science, the Endless Frontier.
Yes.
A report to the president.
Yeah.
This is 1945.
Oh, wow.
This established.
So this went to the president, this right here.
Vannevar Bush was basically the first science advisor to a president.
right.
Okay, and he's advising.
I don't need one of those. Nobody knows more about science than I do.
Really good.
I know.
I'm getting angry over here. Just
That's how you know it.
So here's what I want you to do. Just read the chapter, the section headings there. Just read them. Read them.
Introduction.
Well played.
Okay.
Excellent.
Okay,
The
go.
war against disease. These headings you mean are
Yes.
like
Yeah, just read them.
science and the public welfare, renewal of our scientific talent, a problem of scientific reconversion.
Wow.
The means to an end, responsibilities for the government.
Yes.
The means to an end. Okay.
Okay, so everything I know and think of about how science happens in the United States, when I pull up this original document, it's all there. And so I have, maybe, is it a bias? I say, that's how you do science. But
It's how you do.
are you suggesting there's another way to do science?
I'm suggesting that when you get to the level of how we educate, when you divorce, you understand science as a thing that's about usefulness and
Right.
application.
Yes.
Right.
That is one very small color from a spectrum of colors. And I'm also suggesting that when we look at people who are trained in the history and philosophy of science, along with the science itself in high school, they're testing off the charts in there's something about like being able to answer that or ask that why are we using this equation to solve for the energy level of a hydrogen atom? Why
That
are we
never
understanding
showed up in any of my classes.
That's right.
That's
That's
absent.
right. You were taught. It's amazing
I
to
was
me
taught
that
physics as a thing,
Yeah.
not as a way of thinking. I had to
right.
like realize that it was a way of thinking
Yeah.
and bring to it the bit of philosophical meanderings that I had engaged in my life. I had to bring that to the physics. That was not there
That's
when it was
right.
taught.
and you're told
and-
not to have it there, right?
Well, not
sometimes.
explicitly.
Okay.
It's not encouraged and it's not rewarded.
Okay, let me ask this. So, what is it about asking these big questions?
The why questions.
The big why
Yeah.
questions. What is it about that contributes to the guiding principles of science itself?
because there's no one recipe for how to do good science.
Okay.
Okay, it is true. When I go to my different everybody's got their own angle on the science. It's true.
Right.
There was no centralized
Right.
approach.
Right. Well, but even if there
So
were,
you're telling me that this centralized our approach not to our greater good.
I think it did in some ways to a greater good because, I mean, Vannevar Bush wanted the inner core of funding for NSF to be pure science.
As
He
it
thought there was
is.
always supposed to be a part of it
Whatever
that
funding's
wasn't.
left of it at the moment. As of
Let us hang our heads in a moment of silence.
do I
man.
get a plane from the NSF?
But did you know that if you drop a magnet into a glass of water, it loses its magnetism?
yeah, he said that. He said that.
I love it.
He said that.
Yeah. And by the way, I'm still right. But it has to be Avion water. Sorry. I'm sorry. Go ahead.
Why you keep disrupting the ladies?
I know. I'm so sorry.
Here.
No, it's
Get
good.
back
It's,
to it. Get
it's,
back.
this
Go.
is like real world out there, right? It's like we're trying to do scholarship and then things.
Right.
But also, let me ask you this, Neil. Would you have been interested in doing science if it was just told, if it was taught to you as like following a recipe,
I had to.
like the scientific method, like
my
blue, right?
philosophical interest in the universe was self-driven. It did
Yeah,
not come from
that's
any
right.
book that I was taught.
Right.
And my writings today, I don't want to say they're dripping with philosophy, but they take an angle on the content where it's not just here, learn this. It's think about it
Yeah.
in this other way.
That's very cool.
So, I mean, here's a metaphor, if you like. I mean, a lot of people can follow recipes and make really good dishes, really
Absolutely.
tasty dishes. So there's something wonderful about that. But the truly inventive chefs are the ones who say, well, or even the better cooks. I'm a terrible cook, but like are the ones who say, but why do I melt the butter to this temperature? Why do I add the salt at this stage? Or why is these flavors work together? Expertise is something that our country is not has a very interesting
It's been
tortured
devalued
relationship.
lately, yeah.
That's right.
So let me ask you this. Often philosophy is thought of as a belief system, okay? But in science...
Less so in the sciences.
Right,
Yes,
that's
yes,
what I'm
yes.
saying.
Okay.
But in science, you definitely don't want to be biased by your beliefs.
Good point.
So the one thing you want to do is divorce yourself so that whatever results you get, you're able to accept irrespective of how you feel about them or what you believe. How is that reconciled?
Good.
And let me add something to that.
Yeah.
Okay.
Ooh, there's a lot of good questions.
Let's go back to Kepler, who was, dare I say, philosophically driven to think that the orbits of the planets could be nested in such a way that they resembled the Platonic solids The platonic
Nested spheres, which always makes me think of Tupperware for some reason. But yeah.
So what he knew was that geometrically in mathematics, there are only 5 what are called platonic solids. These are solid shapes where every surface is the same 2-dimensional shape. So a cube is such a thing. Every side is identical and has 6 sides. A pyramid is the same, okay? 4 sides. So you have 4 triangles, and they can all be equilateral triangles. So there are 5 of these shapes. He saw that there were 6 planets, and he thought to himself, maybe there's a divine connection between the two. Because the planets, it's the universe. It's where God lives, right? And then we're just mere mortals here. God surely knows what he's doing, and math is perfect, right? Math is badass. So he nested these in different ways to try to find out whether the separations of the planetary orbits could match what these solids would be if they were nested Tupperware style. Okay?
He was also thinking in terms of harmonic resonances. But yeah.
Right. And so my question to you is, I don't want to say he wasted 10 years. He devoted 10 years to this point of view, and it took him that long to abandon it in favor of something that was not so philosophically beautiful. So in that case, getting back to Chuck's point, the philosophy prevented him from seeing the answer because he was driven by this concept of divine perfection.
So there's a couple of different ways we're talking about philosophy, right? There's the philosophy of if you go to a philosophy section at Barnes and Nobles or whatever, what they have there in the metaphysics section is some weird new agey stuff. It has nothing to do with what academic philosophers are doing.
Okay.
And academic philosophers are asking questions about what is the nature of personhood, what is knowledge. Do different people reason in different ways? What are ethical questions? Like, what is the philosophy of law, philosophy of science? These sorts of things. We have specific tools that we bring to bear on that. When scientists think about it, I think they're understanding not philosophy as a discipline, but they're thinking about a worldview, and we come to everything with a worldview, with a lens.
Okay.
That's inescapable. Now, you're right that part of what scientists want to do is sort of maybe not shield for that, or at least neutralize it in some way. We want to think about whether our comments are value-laden, and I don't just mean value in an ethics way, but maybe also, do I privilege certain epistemic values like beauty or
and many
similarity? And many do.
Many do. But I can tell you this, to the extent that I can understand myself, I leave all philosophical preconceptions at the door.
You can't do that, though.
I said to the extent that I'm able. I'm self-aware that I could be constrained by a philosophical thought. So I remain open to anything I see and anything I measure and what that could possibly mean, and without discounting it. And the reason why I'm going there is I had an issue in Hamlet.
Okay.
One of the lines is, there's more betwixt heaven and earth than are dreamt of in your philosophy.
Right.
And I never understood that comment, ever. Because as a scientist, if a ghost shows up, I'm fine. Let me make some measurements. I have no issue with that. So why does that sentence make any sense at all, until I realized that people who are deeply into a philosophy of belief do close off their access to things that fall outside of their understanding or their awareness. So a good scientist has no philosophy. Otherwise, they're going to miss stuff. Bad scientists will have a philosophy and they'll miss everything.
Your choice to set aside some world, so that you can be neutral, is itself a philosophical position.
Oh,
okay.
That's a very good point.
That is ineliminable.
In a what?
Ineliminable.
That's
that
a word?
you are going to walk
that's a
in
word.
with some interpretive framework.
Ineliminable.
Cannot be eliminated.
Can it be eliminated?
Ineliminable.
I got some big words.
But I would say that the philosophy that I have no philosophy is a very mild version of a philosophy.
The point is that you cannot.
Yeah, I was going to say, she's about to tell you.
I'm listening.
No, she's about to say, that's like being a little bit pregnant.
Let me hear what she said. Okay.
You can't be a little bit pregnant.
Can we hear the lady? Okay, go.
Yeah, well, so when you walk into the lab or whatever,
That's
it's
right.
not like you take off your religious hat or you take off your culture. Like, you're an integrated whole person, and how you were trained and what you were thinking about that morning and what you're predisposed to look for in the equations themselves, those things play a role. Now, there's a huge conversation in the philosophy of science about whether certain things are more or less appropriate when you bring in, but that you bring something with you, that is how we do. Science is a personal and social endeavor.
So all I did say, I think, was I reduce it as much as I knowingly can.
That's what you said.
So
but what
that-
she's saying is there's no extent to which you can actually know, because the holistic person that you are inexorably tied to your philosophy.
Except-
even when you try to divorce yourself.
Except
from
in the movie.
So you guys are talking about a philosophy like, and I think this is fair because I think a lot of people do this,
ahead.
like it is a political position. But I'm talking about something, not just I'm talking about the way you view the world.
Now watch.
More
In
comprehensively.
this show, do you remember the show?
I like that.
The
Okay.
X-Files.
I like that.
Of course, man.
Okay, so
Best
now-
show ever.
Okay.
X-Files.
The X-Files.
Yeah.
I'm watching the show.
Okay. Yeah.
Okay. And there's like the skeptic science
Scully.
Scully. And then Mulder.
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 Right.
Moldau. Moldau.
Excuse me. Mulder. And
That's
I
right.
watched them interact, and I'm thinking, no. Okay. There was some glowing mass in a vestibule. Okay. And Mulder says, "Oh, this must be an interdimensional." He just goes right to the most wild explanation for it. And Scully is saying, this can't possibly be real. It must be a projection. And she's all discounting of it because it doesn't fit her philosophy that can't exist. And I'm telling
You're making my point for me right here, right?
Good.
Fine.
Fine.
It is the chemistry of those two perspectives that leads them to certain discoveries and so on.
You call that they look pretty immiscible to me. How's that for a chemistry word? Do you
That's
remember
good.
immiscible?
Immiscible.
Oil and water, immiscible.
Yeah, don't mix.
You know how to missile them?
I do not.
You take a little bit of, because when you're making...
Are we talking about Scully and Mulder?
Yes.
How do we do it?
How do we get the vinaigrette?
I learned this in chemistry class, and then I applied it at home. So you have oil and vinegar,
Right.
And you shake it, and it'll still separate.
Right.
Yeah.
exactly.
It's together for like for a few
4
seconds.
seconds.
All right. But you can get an emulsifier to put in there, and it'll connect chemically to both sides and bring them together.
How?
So I think, if I
I don't
remember
wanna know the
correctly,
answer.
a
We don't
little bit
have
of
time
egg
for
yolk will do that.
Egg yolk is an emulsifier. That's
Yeah,
right.
that
I
makes
know that
sense.
from baking.
Believe it or not, and I was going to say that's egg yolk is used as an
yolk's
emulsifier in a lot of
Yeah.
a lot of
so,
cooking.
So it brings it together. So they needed egg yolk.
Fair enough. But I mean,
But I like what you're
even-
saying. You're saying
yeah.
this is not philosophy in terms of I believe, blump, blump, blump.
Right.
It is philosophy
worldview.
in terms of...
How do you know what questions are good questions
Right.
to pursue? How do you know when your apparatus is measuring what you want it to measure?
Well, let's
Stuff like that.
anchor this back in time. Please compare for us the philosophies of the two greatest physicists there ever were.
Okay, so
Who do
you
you
said
think
this.
they
So
are?
I was going to say, so he's talking. So one of them has got to be Isaac Newton.
Yeah,
that's got to be one.
Newton and Einstein. So,
And then-
so
yeah.
tell me, because you've
Good.
clearly you've studied this because you're writing about the man and everything.
Yeah.
So, and I love the fact that we share sort of access to history.
Yeah.
And what that means in
Yeah.
the present.
Yeah.
So, I just want to know, how would you characterize Newton's philosophy relative to Einstein's philosophy? And I have here. Hang on. Before I earned enough money to buy an actual book from Isaac Newton's days, I got this paperback called Newton's Philosophy of Nature.
Yeah.
Okay, little paperback,
Selections from his
and
writings.
so it's not only from his great books but also his writings.
Yeah.
Yeah. So
May I?
no, that's just a paperback. Yeah, I thought I was
It's
thinking
not
it was,
your original.
I don't know. I thought it's my
Yeah,
original.
It's not
Newton.
your
He's holding
original.
it like it's a teddy bear or something. This means
Yeah, but see, I've been
something
all
to
up
you.
in it. Right?
You've
I
been
see.
up
You got
in it.
every
I'm
all
saying.
the
That's
pages
great.
are
Yeah, I've had
dog-eared.
this since
Okay.
middle of high school. And
Good.
Yeah. So me and Newton go back. And don't you badmouth Newton in
No,
this
I'm
office.
not going to badmouth Newton. I love Newton.
Good.
He's a primary source in my philosophy of space and time class because
That's
students.
a class you take.
It
I
is.
want to take that class.
I would love to have you.
Can
I'm
I- can
teaching
I
it in the
some-
fall.
Okay.
Also, Einstein as philosopher is a course I'm teaching in the fall.
Got it.
Anyway, Newton was motivated, at least in developing, by many things, but in developing in particular his theory of gravitation in an essay called De Gravitatione. I don't know how to pronounce the Latin, but there it is. He's responding to Descartes, who had 3 laws of motion. But Descartes thought that all motion was relative. And so it is in developing his response to Descartes' theory of motion, entirely on philosophical grounds. He is reasoning from his armchair how he can understand motion.
He must have had a badass armchair. That's all I'm saying. I want to sit in that
He
chair.
also invented the calculus from that same armchair. Einstein is responding to Newton. He was bothered by the fact that in a fully physical worldview that Newton said he was presenting, you nevertheless had a background space-time that was influencing matter, but not itself able to be influenced by matter. This asymmetry of dynamics bothered him.
So let me restate what I think you said. That Newton is describing a universe embedded within space and time.
Sort of a theater, background in which
it's
matter...
a theater set.
Yeah,
yes,
that's
okay.
right.
And so whereas Einstein wanted the theater set and the players in the theater to interact with one another.
That's right. And in particular, Newtonian mass is inertial mass. It's an intrinsic, in the old school philosophy tradition, it is a property that belongs to the thing in virtue of the thing itself. This mass.
Yeah, just remind people, Weight Watchers is really mass watchers.
Right.
If you want to weigh, let's just go to the moon.
Yeah, go to the moon.
There you go.
Thanks, Oprah.
There's a lot of ways to weigh less. And so,
but how do you get the money to go to the moon in the first place? But
I just want to just clear. So when you reduce your number of fat cells in your body, giving it up to energy, then you're reducing. It's a mass you're cutting from yourself.
It's supposed to be some deep, essential, meaning essence of the thing. This also bothered Einstein. He didn't think that things should have innate properties in this way.
Wow.
And so one of the things that motivated him going from special to general relativity was a paper he wrote in 1913 where he predicts gravitational waves, by the way. So he didn't want mass to be something that just belonged because God decreed it thus. And so he developed a way of accounting for mass that was also dynamical. We give something inertial mass because it's following a geodesic. It's following a particular path through space-time. And that is why we call something having inertial mass. It is not an intrinsic feature of the thing itself.
A geodesic on Earth is a path that you would take where if you sliced through that path, your slice goes through the center of the Earth. So it turns out if you do the math, it's the shortest distance between those 2 points.
That's
right. So that's why you see on a map, you see these
the loops
plane
that go
map,
back and forth.
they have arcs.
Right.
If you made that a sphere, that would be the shortest distance. We call that a geodesic, meaning Earth, but now you're taking it and using it for the whole universe.
Because another thing he was doing in this 1911, in these papers when he's developing what's called the Entwurf, like the in-between theory between general and special relativity, he's working toward general relativity, publishing along the way. And he's realizing that the effects due to acceleration are the same as the effects due to gravity. So acceleration and gravity are like two sides of the same coin.
So every time I hear it, I'm like, this is so brilliant.
It's so
bananas.
It's awesome.
It's simple and brilliant.
But he was motivated by Newton's account not answering his why questions. This asymmetry between like space and time being this God-ordained theater in which things happened, but the things themselves couldn't affect space-time, was a principal motivation for his wanting to dig deeper and come up with a theory of space and time and gravitation that wasn't ordained on high.
Didn't he apologize to Newton?
I have no idea.
Did
Einstein apologize to Newton? Perhaps in jest.
I have a memory because his whole general theory of relativity supplants Newton's gravity.
That's
and
right.
I think he apologized at some point.
Well, it's got to be one of those sorry, not sorry.
Yeah, I was going to say. Is it like the way you apologize to Pluto? I mean,
it was like you can also apologize to somebody while saying, but I did a better job, right? Like, he's still clearly
sorry for blowing you out of the water.
It was like, but also, we're building on the people who came before us in developing our viewpoints of the world. So he owed a great deal to Newton.
So this started with Descartes, is what you're saying?
Descartes himself took 3 laws of motion from Kepler. Kepler's.
Kepler has 3 laws.
This game had been going on for a while.
Yeah. Wow.
Yeah.
from a philosophical standpoint, all of these are philosophies.
If you mean it in the sense that they're trying to ask the deeper questions
they're-
of why do the things that I observe
I got one
behave the
for
way
you.
they do. Yeah.
Why does Newton have only 3 laws of motion and not 4 or 2 or 10?
He thought that 3 laws he describes this in the General Scholium at the beginning, which is all philosophical arguments for why he thinks absolute motion can be differentiated from relativistic motion. And he needs relative motion.
I'm talking about Newton.
Yeah, Newton,
Yeah.
the General Scholium.
You said
at the beginning.
relativistic, and that
I meant
sounded a little...
relative motion.
Relative
I'm
motion,
sorry, from Cartesian or Descartes' relative motion. He thought that that's what he needed to give all of the account of all the motion.
We come out of Newton, we go through Einstein, and these are still, they still make sense even if they're weird. You can still see why they make sense mathematically. But you go into the 1920s, and then quantum physics descends, and nothing makes sense. But it works. It works. You can make predictions. The understanding of the periodic table of elements, of molecules, of atoms, all clicks into place, and everybody's scratching their head. So what does a philosopher do then?
All the things. It's so much fun. Yeah, so...
You just like it when we don't know what we're doing.
No. I think we would say that all of physics involves interpretive moments, but they're particularly painful in the case of quantum mechanics, and it's fascinating. Let's go play. Like, let's go talk about it.
There's a word for that. It's called sadomasochism. It's particularly painful. Yeah, let's get it.
Yeah, but I mean, but it's also like these are the questions that keep you awake at night. There's
Yes.
pain,
Right.
but joy.
Yes. So
It didn't come out of nowhere, right? I mean, there was an old quantum theory that Bohr and Sommerfeld, who was a physicist in Munich, had been working on in the 1910s to account for atomic spectra.
Sommerfeld or Sommerfeld?
Sommerfeld.
Sommerfeld, yes. Okay.
Sommerfeld. I pronounced it in the German way.
Oh, excuse me.
Okay.
I saw an S there, so I just said Sommerfeld.
Sommerfeld.
I had one of his books. Yeah. Okay.
Yeah. He was really important. He was also the doctoral advisor of like Heisenberg and Pauli and a lot of these guys who went on to be important progenitors of the new quantum theory. But they were trying to understand these empirical data, right? The spectrum.
By the way, every one of these people got a Nobel Prize.
Oh, yeah.
Every one of them down the list.
Einstein's Nobel Prize was not for relativity.
I
It
know.
was for the photoelectric effect, which
Yeah.
was dealing with quantum
And Brownian motion.
and
Yeah.
Brownian motion. Yes, that's
Yeah.
right. Brownian motion, which is to do with getting macroscopic about quantum effects.
Wow.
But yeah,
So Brownian motion, you suspend a particle.
like a
You get-
pollen grain, like pollen.
Yeah,
It's,
you put it in a fluid, and it just bounces around.
yeah.
And that wasn't fully understood. Like, what's going on?
Right.
Looks like it's random motion.
Right,
Yeah.
right. And then you have to calculate there's particles hitting it.
Right.
That are smaller than it, that are hitting it. And you realize there are more molecules of water in a glass of water than there are glasses of water in all the world's oceans. And we didn't have insight into that until Einstein explained Brownian motion. To understand what the hell is going on in there.
Yeah, we don't know inside, like the insides of atoms
Yeah.
very much yet. Like
Yeah.
there's so
Right.
little known about the structure of atoms. And so that's partly what they're debating. And part of what allowed Heisenberg and Pauli and some of the people working at the forefront in the 1920s, they were looking at these descriptions. You remember Bohr's planetary model of the atom, right?
It's part of why we call them orbitals.
Right. Yeah, because
Right.
he made it look
orbits.
like
Yeah.
But there are huge mysteries with this model. It doesn't account for all the spectrum, the data of the spectra they're seeing.
Mm-hmm.
I'm using all the right Latin plurals here, I hope. But also, how is it that it jumps from one energy level to the next, and it does it discretely? That's right. It does it quantum. Like there's no actual physical motion from one place to the
What
other.
does the philosopher say about this?
yeah.
Well, they were Bohr and Sommerfeld in
You
the
haven't
old quantum
explained.
theory.
You've been here sitting here for a half hour.
I'm
You
about
have
to
not-
deliver the coup de grace. If you would shut up.
Okay.
All right.
Okay, go.
All due
All right,
respect,
Elise,
sir.
finish
Sure.
him.
Yeah. They were trying to describe the electrons using classical terms for particles, position, momentum. Heisenberg said, what if we use totally different things to describe the electron. What if we tried to write down, instead of equations of motion in this classical way, we think about the electron in terms of wave, like by writing down the intensity, by writing down the amplitude.
Like a wave.
Yeah, sort of. But he didn't use quite that language, but he said, let's look, he used what's called Fourier, like Fourier, another French term, Fourier, analysis, to look at it. And he got these equations out that worked. And it was only by sort of stepping back and saying, the language we're using is presenting to us a world that is a classical
That's a
world.
philosophical pivot.
It was a new approach. It was a new lens for looking at the problem. It was a new lens for attacking the
Right,
problem.
because if you believe or you think that these other metrics are what actually matter,
Right.
and if they don't actually matter, you're going to get the wrong answer.
And Schrödinger continued to argue, like he developed wave mechanics in 26. Heisenberg did this in 1925.
1926, yeah.
Yeah, so right on the heels of this, Schrödinger gives a description in terms of wave, and everybody knew, we love waves. We see waves everywhere. Sound waves, water waves. We understand how waves behave at the macroscopic level. And so when Schrödinger gave a version of quantum mechanics that was all written down in terms of waves, people said, I can visualize that. I can understand how to model that. But it didn't quite do all the things Heisenberg's matrix mechanics did. But they were arguing about these viewpoints in a philosophical way. Like, what do we need when we have a full scientific theory? Do we need to be able to visualize in space and time what's going on? Or do we need the right equations?
All right, so they did their duty, and we're now 100 years later.
We are 100 years on.
There are certain quantum questions that the layperson sees unanswered over that entire century. How can two particles be entangled? What does that even mean?
Right.
And how is it you observe it over here and then
it's
instantly,
instantly-
it's not even the speed of light, it's
Right.
instant.
Yeah.
And people want to wrap their head around this, and you have not given us an answer to it.
Yeah, at least what's
We
happening.
haven't figured it out yet. It's an ongoing puzzle. It's an
in that
ongoing
case, you're forgiven.
conversation.
Well, maybe it's not something to be figured out, it just is.
Here's where this
Ooh,
matters. If
now-
we're trying-
No, think about it. No, I'm saying maybe you're trying to bring a classical sensibility to something that has a different reality.
I agree with you. And I get a lot of shit for that in the philosophy community. I think a lot of the interpretations of quantum mechanics that are proposed are trying to tell a story about how we get from a probabilistic set of solutions to an actual solution. And I think the world just makes a choice. There are some dynamic considerations in there. It's a much more nuanced story than what I'm giving you right now. But I think you're right that we're still like very much moored to these classical
Because classical
pictures of the world.
Classical pictures make sense in an armchair. But you start saying particles pop in and out of existence,
Right,
they tunnel,
right.
they do this and that.
Yeah.
And I, as a scientist, as an astrophysicist, I accept what quantum physics does for me to understand what the universe is doing. And I've learned to not lose sleep over trying to understand why.
If you were working in quantum cosmology, you would want to know, because we don't have a theory yet that brings
Big Bang.
together that brings together general relativity
When the large was small.
and quantum mechanics.
Right.
And in fact, most of these interpretational debates are happening with respect to non-relativistic quantum mechanics. But we know that the final theory, we think, will be relativistic. It'll be a relativistic quantum
So
field theory.
you foresee philosophers helping the physicists towards this goal?
I mean, having a conversation with, I would say, and I would say the physicists are also having this conversation.
Yeah.
So, for instance, there's a real question as to whether certain inflationary paradigms that are thinking about how we get to effectively classical like field modes for the different parts of, gravitational field modes or, matter field modes, whatever you want. But we think the initial state was a quantum one. So we need to know a story about how we get from a quantum state to what looks like
we are now.
That's right.
Because you're saying that if there is a model that makes sense, it started with the field. It started with kind of like what we would call nothing, but really it's everything all at once being nothing.
Yeah.
And then out of that, pop, and then boom, and then all of this.
No, it's everything everywhere all at once.
Oh, I'm sorry.
You left out one of those.
I gave a talk on entanglement that was about that. Had that title, but I watched the movie on the flight and had to cross that title out. I was like, it's not quite what they're doing there.
So
But some of the
if
question
I
is-
understand you
yeah,
correctly,
yeah.
we went from a quantum state to a
To a
macroscopic
macroscopic.
classical state.
Right.
And there had to be a transition somewhere in there that allows us to bring these sensibilities together
That's right.
in a coherent understanding.
Well, even when we're trying to understand what the universe looked like in those early stages before we got to the big asymmetric distribution of matter we have now, those are stories that rely on our understanding how we get classical field modes, classical values for field modes out of a quantum soup. And so these questions show up there. Here's another
But are they being answered by your brethren or by...
They're not being answered by anybody. At the moment.
Anybody?
We're talking about them together. And there are, some cosmologists who want to understand, like these early. They're asking whether or not whether we could find residue of entanglement from this early state. And that's where I say, even as a philosopher, no, because entanglement relations are going to be so damped down by interactions with the gravitational field mode and all these others that we could never measure them.
Okay.
But that doesn't mean they're not a part of the story. So we're having conversations with one another about these things because the answer is unclear.
All right.
Yeah.
Well, there's still
Wow.
always mysteries. You better get back to work.
I don't know. Give me my gummies. Give me
You need
get my
some-
edibles, please. Get my edibles right now, because damn.
I'm a philosophy professor. I should be on board. Like, I've had the worst experiences. I just can't do it. People
yeah.
around
There are no
me just,
edibles in this office.
Yeah, there we go.
Okay.
People are like, is your color red the same as mine? I was like, yeah, Hobbes thought about that 2000. Like, who cares? Let's go on from that.
Leviathan Hobbes? That Hobbes?
That same Hobbes.
Okay.
Yeah, we all thought about
Not
that.
Calvin and Hobbes. Just
That's the
verifying.
Hobbes. Calvin is named after John Calvin, which is, John Calvin.
John Calvin.
And Hobbes is named after Hobbes, the
Calvin as in Calvinist.
Calvin and
Calvinist.
Hobbes is named after John Calvin, the Reformed theologian.
Yes.
Right.
Yeah.
And Hobbes is named after the philosopher and political theorist Hobbes.
And how about the tiger?
And
the tiger is Hobbes.
the tiger is Hobbes.
Oh, that's
tiger is
Hobbes.
That's Hobbes.
Oh, I forgot that.
Okay.
Yeah.
And
This is super important.
now, who is Marmaduke named after?
Thank you. That's the one.
Beyond my realm of expertise, y'all. This is beyond my realm of expertise.
All right, we got to land this plane, but this has been highly confusing. Simultaneously enlightening
you.
and confusing. Is that possible?
I have to say.
Do you have a word for that? To be enlightened and confused at the same time?
To be a philosopher.
There you go.
Full circle, people.
Oh, hey.
That was the way. That's how you do it. Full circle.
Well, let's keep talking about it at some point.
yeah.
Not now. You have other things going on.
So that brings us to a close. Sorry we didn't fully answer everybody's questions.
Well, there are none. The answers. The answers are out there, Scully. No, the answers aren't known yet.
No, you know what it is?
That's the
It's-
beauty of it.
Seek, and you probably won't find.
Seek and you will find what's maybe not the case.
Oh, that's a good one. I like that.
Pop here.
No, seek, and you may find the answer to the question you have not yet posed.
There you go. Ooh.
Oh, wow.
That's
Let me tell you
juicy.
something. Jesus
That's
is
good.
happy he didn't say any of those things. People would have checked right out.
Like, and see. Yeah.
All right. What fascinates me most about the frontier of science is to do it right. Yes, you got to keep at least 1 foot in the perimeter where we at least think we know what's going on. And then you put the other foot outside and test the waters for new ideas, new perspectives, new ways to think about how the universe works. But for me, it may be a specious goal to believe that the more you do research, the more you understand about the universe, because what remains true is that as the area of our knowledge grows, so too does the perimeter of our ignorance. And if that's true, that might mean that science is indeed the endless frontier envisioned by Vannevar Bush in 1945. That is a cosmic perspective. Thank you, Elise Crull.
Thank you.
Yes, thanks for coming down to share some of your vision and expertise with us here.
Yeah, it was great.
All right. Chuck, always good to have you, man.
Always a pleasure.
This has been StarTalk, the quantum philosophy edition. Neil deGrasse Tyson, as always, bidding you to keep looking up.